Hello and welcome to the NIE Sustainability Learning Lab video series on water quality. Today we're going to look at two related and yet different water quality parameters, turbidity and suspended solids.
Prof, when you say that turbidity and suspended solids are related yet different, what does that actually mean?
That's a good question, Grace. What we see is that turbidity and suspended solids really are measuring some characteristic of suspended sediment in the water. So in this way, they're related. As we'll see though, they're also quite different. As we see in this graph for the Mekong River near Phnom Penh, Cambodia, there's a strong relationship between suspended solids and turbidity. On the y-axis, we have suspended solids in milligrams per liter. On the x-axis, we have turbidity in nephelometric turbidity units. A greater concentration of suspended solids results in a higher turbidity. So as we see, the two properties are measuring some type of characteristic of suspended sediment in the water. And yet they're different because they're measured in different ways, Grace. The turbidity is an optical property. It's measured using some type of visual device that looks at the clarity of the water. On the other hand, suspended solids is a gravimetric type measure, and so what we're really doing is looking at the suspended solids concentration in the water, and this is done through filtration. Probably the best thing to illustrate the difference between these two parameters is to actually show everyone how they're measured. So Grace, could you start by showing us how turbidity is measured, please?
Sure, Prof. Turbidity can be measured using a number of different approaches, depending on your budget and also the depth of the water. One of the simplest ways to get a measure of turbidity is to determine the Secchi depth. If the water is deep enough, as we see here, we can use a standard black and white Secchi disc. We simply lower the disc into the water until we lose sight of the disc. As you can see now, we can no longer see the disc. As such, this is an optical property. We can now measure the length at which we lost sight of the disc. As we can see here, the Secchi depth is about 56 centimeters. If the water is too shallow, we can use a Secchi tube instead. The Secchi tube has a Secchi disc that is smaller and located at the bottom of the tube. It also has a graduated scale that measures the depth in centimeters. First, we have to fill up the tube. Fill it up to the arrow mark. We then have to lift up the disc and lower it into the tube until we lose sight of the disc. Once you can no longer see the disc, use the graduated scale to determine the Secchi depth. In this case, we can see that the depth is about 36 centimeters. The PUB test kits, which most of you are familiar with, also provide their own version of a Secchi disc, as we can see here. A higher tech measurement approach is to use a turbidity sensor, such as the YSI 6920 data sonde. The sensor emits a light beam, which is scattered by the sediment. With less sediment, there is less scatter. We'll discuss more about the YSI in another video. Turbidity and Secchi depth are related and can be converted using a graph such as what we see here. Sometimes we have to be careful, however, because Secchi depth can also be affected if there are high algae levels in the water. Suspended solids concentrations are determined by filtration. First, we need a known volume of the water sample. This can be between 100 and 500 milliliters of water, depending on how much sediment there is. In this case, we are using 200 milliliters. First, take a new glass fiber filter that has been weighed in the lab and place it on the filter holder. We then filter the known volume of water sample. The manual pump that we're using helps to create suction that draws water through the filter. The water is now fully filtered. As we can see, there is sediment that has been collected onto the filter. We place the filter in a drying oven and dry to a constant weight at 103 to 105 degrees Celsius. If you have many samples, you may need to place the filters in a desiccator before weighing them to keep them dry. Weigh the filter and sediment and then subtract the empty filter weight to determine the suspended sediment concentration in milligrams per litre.
Thanks, Grace, for those demonstrations. As you can see, in both cases, we're interested in suspended sediment in the water. However, again, turbidity is an optical property, whereas suspended solids is a mass property that is determined through filtration. Generally, in ecology, turbidity is more important. For example, if a fish is a visual feeder, it needs to see its prey in the water. If the water is too turbid, the fish can't hunt properly and not get its food as a result. On the other hand, if you're a geomorphologist, you're more interested in erosion in the landscape. And in this case, you need to know how much sediment, the mass, the total tonnage of sediment that is leaving the watershed to know how the landscape evolves. Regardless, what we do know is that if the sediment concentration in the environment is too high, it's going to have a negative impact. For example, too much sediment can clog the gills of fish. It can cover the eggs of fish, and so they will not hatch. Too much sediment can also fill in drinking water reservoirs, so that reduces our capacity to provide clean water, fresh water for our cities. In the end then, we can see that suspended sediment in too high a concentration can have a negative impact on the environment, and this is why we want to monitor.
I see. Thanks, Prof. The turbidity has definitely cleared up now.
Generally, during storm events, the suspended sediment concentrations in our waterways increase due to soil erosion, riverbed and bank erosion, and in the case of cities, street runoff. This is why, for example, runoff from construction sites in Singapore is highly managed. If the soils are left bare, they erode easily, and this impacts our waterways.